Hello, for this problem, we're given a velocity vector of the hockey puck shown here, and we are asked to do basically take the vector format, so the x and y components that we have here, and determine the magnitude and direction of the velocity with respect to the axes given. So I've got x and y axes here. So I'm going backwards from what I've done in the previous two problems. And I still want to start by drawing out my triangle. So I've got x and y, kind of like this, and my hypotenuse is as shown. And so in this case, I don't know the direction or the length of the hypotenuse, but I do know the two legs of this. And so in the x direction, I've got 5 meters per second, and in the y direction, I go down 2.5 meters per second. So I'm looking for angle theta right here, and I'm looking for the magnitude, the length of this vector right here. So the magnitude of the velocity, I'm going to use these bars to indicate magnitude, is going to be simply found through the Pythagorean theorem. So a squared plus b squared equals c squared. So the length of that hypotenuse is the square root of 5 squared plus negative 2.5 squared. And that, if I do those calculations, I should get 5.59 meters per second. And so that is the overall speed of my hockey puck. All right, next I want to find this angle theta. And so this angle theta, I'm going to use what I know about the tangent. And so the tangent function is the ratio of the opposite side over the adjacent side. So I know that the tangent of this angle theta is 2.5 over 5. So I'm going to use the inverse tangent function. So tan negative 1 of opposite over adjacent. So 2.5 over 5. And that will give me, if I use that inverse tangent function, I can figure out the angle. And that angle in degrees is 57 degrees. All right, so now I know the angle as well. And I'm going to just simply redraw this for the solution. So I've got my y, x vectors here. Those are my axes. And the overall magnitude of this is 5.59 meters per second. And this angle, it's going to be down 26.57 degrees. And so with that, I've taken kind of the x and y components up here and converted it to a magnitude and a direction for my vector. Thank you for watching, and I hope to see you again.